Welcome to the fifth video in the series on building your own private, secure compute environment. In this video, I'm going to be focusing on security cameras, both the cameras and the software package needed to go and record and alert you on events that your cameras find. This will be kind of long, so if you don't want to listen to me drone on for a while, I'm going to break it into a couple sections for you. The first section will be on hardware issues. What kind of computer do you want to have in order to run the software package? Talk a little bit about disks. What's the difference between a surveillance disk versus a standard data disk? And remind you a little bit about the networking issues around making sure that your data stays on your systems only and that your cameras don't go off and start talking to who knows who. The next section will be on the cameras themselves. What's ONVIF versus RSTP? And what are some of the options there you have for choices for cameras and what might you be looking at? I won't make any specific recommendations, but I will be pointing out some of the things you might want to be thinking about. And then we'll talk about Zoneminder. That is the software package that I'm going to recommend for the security camera, capturing the data, storing the data, looking at zones, alerting you for events. And Zoneminder is one of many good choices. It happens to be Linux-based, which I like for something that's going to be running 24 hours a day, nonstop. There are other excellent choices. Blue Iris comes to mind. That'd be appropriate if you want to be running Windows-based. My personal take is Windows running 24 hours a day. There's just a lot more stuff in Windows. It's a little bit harder to keep it focused on just what you want to have, but you can make it be perfectly secure. You can make it be perfectly reasonable. Not a bad choice if you choose to go that way, but I won't be talking about it. And then I'm going to go through the final section is going to be actually putting it all together. I'm going to boot up a Linux OS, install the packages, take a camera, connect it up, and start recording on a couple of cameras and show events and show event alerts being sent by email. And we'll talk a little bit about the advantages there of email alerts versus something that's a little more instantaneous. If you want to have a Ring camera equivalent of who's ringing the doorbell, email won't quite cut it because there's a minute or two delay between the time it sends it and you see it. So we'll just talk about what some of the other options are on that one. And that should be it for this video. So let's start with hardware requirements. First off, what you're going to need for a processor is going to be dependent on how many cameras you want to have and how fast they're recording. And by how fast, I mean frames per second. And of course, the resolution of the camera. A 4K camera running at 30 frames per second is an awful lot of data, and it's going to take a certain amount of processing. And it's also going to take a whole lot of storage. So I often recommend that unless there's a particular need for 30 frames per second, you probably want to slow that down a little bit so it's not quite so heavy duty. My personal system is running a Intel Atom processor with 16 cores. That's a blast from the past. But each camera takes about one core. So any modern processor would be able to take several cameras per core. So if you have 8 or 10 cameras, you probably want to have something with a 4 or 5 core processor or something along those lines. You're going to want to be fairly sizable. And that is going to be dependent on, again, the resolution and the frames per second. I found that it isn't too heavy a load. If you're going to have 15 or 20 cameras, then you're going to want to have a reasonable higher end Intel or AMD processor to do the processing for you. You'll also want to make sure that you have a certain amount of memory for it. My system has 128 gig, but it runs all kinds of stuff in addition. So certainly going to want to have 16 gig, maybe a little bit more than that for 5, 10 cameras. On the network, we've talked before about making sure that your cameras are not able to talk out. Half of the cameras that I've purchased try to talk out at some point or another. I don't know where. I don't want to find out where. They are definitely not a local IP address they're trying to talk to. So what I do is I put all my cameras on a separate subnet That's a 192.168 dot something or other. And I put them all on that one. And I make it so that that subnet really can't talk out, except that I allow the security camera software to talk out. Everything else isn't allowed out, and it's just blocked if they try. And the nice thing about using pfSense for a router is you can actually put up an alert that tells you this particular device is trying to talk out, if you want to find out who it's talking to. Or you may not care, just make sure it doesn't. I keep bringing up the need for security on IP cameras. Here's a rule that I have on my firewall where the rule just before this allows any device on the camera to talk to the firewall itself, so it can get NTP's time server and things of that sort. And then I take any IPv4 or IPv6 of any protocol, of any type, and I block it. And just for now, I actually said, let's go and log the packets that are handled by this rule, which means I should now see all of the packets that get blocked when I go and look in the log files. And I'm going to do that right now. So if I go to status, and I'm going to go take a look at system logs, and I'm going to take a look at firewall. Well, at the very top, you see all the kinds of just general noise coming in from the outside. But even here, you can see these happen to be some of my cameras right here, and you can see them all trying to go out. But I'm going to go and sort by source. And I keep my cameras on 2 different addresses just for, well, some routing reasons. But here you see the cameras. They are trying to talk to, this is trying to talk to a DNS server that it's not allowed to talk to. And here you see it trying to go out on all various kinds of port 32100 to who knows where. This is one camera trying a lot of different ports. And after that, there's going to be another camera, and there's another camera, and you can see them busy trying to talk out. This one's just trying very hard to get out to an NTP server, or sorry, a DNS server. And it's still trying that. And here it's trying to send out some data on who knows where that is, who knows where this is. And it just goes on and on and on. And this is just, I don't know, 15 minutes of it or so. It's a lot. And that's just those cameras. And then there's a whole other set of cameras somewhere down lower. But I think the point is made. So what are these accesses doing? Probably the best case is that they're simply trying to take your video that's being recorded and send them off to some other place to be looked at. There are, however, even worse possibilities, and one of them is that it's trying to set up what's called a residential proxy. These are devices that are now inside your subnet talking out on your public IP address. Well, they would be if they were allowed to be. And one thing that a variety of places use is what's called residential proxy, where somebody else uses, in this case, your IP camera as a way of talking into your IP camera and then having it go and send it back out so that it appears to be coming, whatever access was going on, appears to be coming from your IP address. If it's something illegal and the authorities find out about it, they will be calling on you to ask what you've been doing. It could also be used for botnets, which are devices that are meant to basically break websites for a fee. In any of these cases, it's using your IP address for things that are not for you. So in the security camera software, surveillance software, you could do 2 things. You could either have it have 2 internet ports, one that is allowed on a network where it's allowed to talk out, and another one where it can just listen to the security camera subnet. Or you could have it just on the security camera subnet and then tell your router firewall that that particular device is allowed to talk out. None of the others are. Either one should work fine. Next, let's talk about disks briefly. I should have talked about this in the cloud video, but I didn't. There are a lot of different kinds of hard drives out there. There are SSDs, solid state drives, and they can be great for normal data usage. That is, for running your Nextcloud or for running something where you're storing files back and forth. They tend not to be a good choice for security camera software. And the reason is that, well, there are two reasons. One, the speed is completely lost on security cameras, but the lifetime of SSDs are defined by the number of writes. And security cameras are going to be writing to the disk all the time, continuously, 24 hours a day, lots of them. So you're basically going to be aging your SSDs rather quickly. So aside from them being expensive and far faster than you need, they will also die sooner. For good old-fashioned HDDs, hard disk drives, I guess is what that stands for, there are a couple different types. There are sort of the consumer drives. They are expected to be turned on for an hour or two and then turned back off. You don't want to be using those for a cloud controller, nor do you want to be using those for security camera software. Again, where the security cameras are running 24 hours a day, your hard drives had better be set up to run 24 hours a day. So there are two main classes of hard drives for 24-hour use. Some are focused on NAS, network attached storage, and that's what your next cloud server would be. And that's where you're going to have data written back and forth. Occasionally, you're going to write a little bit here, you're going to read a little there, you're going to read this file, you're going to write that file. Those are standard. If I look at Western Digital terminology, they're just one of many perfectly good choices. That's where they have Western Digital Red Pro, at least right now they do. I think they're changing some of that. And those are meant for network attached storage, 24 hours on. They tend to be running at 7,200 RPM. Not crazy fast, but not really slow either. So they have pretty good response time. They are meant for Nextcloud. They're perfect for Nextcloud. For video surveillance storage, you want something a little different. And they're actually surveillance hard drives. Going back to the Western Digital terminology, those would be their purple drives. And they are meant for continuous low-speed writing. What is the difference? One, they're running slower. They run at 5,400 RPMs. That's helpful for, they use less power, which means they don't get as hot, which means they run cooler, which means they run more economically, and they also live longer. And they are really meant for low speed, continuous writing, and occasionally reading them back. And that's exactly why they are meant for surveillance camera systems. So if you don't know that you're going to be using these disks for 24-hour surveillance cameras, so if you're just playing around with it a little bit, you might want to get NAS drives and just use those. If you know that you're building a long-term surveillance camera system, then you probably want to get surveillance camera optimized hard drives. And every major manufacturer will have drives built for surveillance systems. And so that's probably what would be appropriate there. They'll be a little cooler. I think they'll be a little cheaper. They will last longer for this particular use, and they're a little slower, which is fine. So let's talk a little bit about IP cameras. First off, there are a couple different ways that they hook up. Some IP cameras just have an antenna for Wi-Fi and the ability to plug into power. And if you don't have a Wi-Fi cable available, then that is probably a really good choice. There are other cameras that are using what's called PoE. So that'll run your Ethernet cable, will run not only the data to it, but it'll actually run power in there as well. Same cable as your normal Cat6, Cat whatever cable has the ability to run power and data back and forth. And so the nice thing about that is if you have a switch where it's got PoE injection, or you can just buy a little PoE injector box. It's a little box about that big, plugs in the wall outlet and just does power injection into the cable and lets the data go through normally. Then you have the ability of running a single cable to wherever that camera is mounted, and that camera now has power and data and can talk through the Ethernet cable. Some advantages of that is that if you are very security minded, well, you can't jam Ethernet very quickly. You can jam Wi-Fi without a whole lot of trouble. So it wouldn't be too hard to force a Wi-Fi camera to get disconnected. It's a lot harder, unless you cut the cable, to jam a PoE Ethernet camera. Your call. Then there are two protocols that I'll talk about. One of them is an interface. It's called ONVIF. Don't ask me what it stands for, but I'll type it in right here. And that is a open standard that allows a camera and a surveillance camera software to communicate over what protocols does this camera support in an open sense. And so any camera that is ONVIF capable will be able to communicate with a surveillance camera software to communicate what are the things that the software can do with this camera. It's useful. I won't use it much in what I'm going to be talking about, but it's something to consider. The other one I want to talk about is RTSP, which is a streaming protocol for video. And that one, in my view, is required if you want to be using Zoneminder. There are other protocols out there, but RTSP is standard, and Zoneminder is really good at listening to RTSP. And the RTSP is just the live stream of footage from the camera that goes right into the Zoneminder video software. That is what it collects, that is what it analyzes, and that is what it stores on the hard drives for you to look at later. There are many, many, many choices for cameras. One of the things I'm going to point out is that Zoneminder does have built in some camera manufacturers. So if you want to be doing tracking control and things like that, it has the tracking knowledge for some camera manufacturers built in. You can add on your own if you know how to do that and you want to go explore a little bit. But if tracking and things like that are of interest to you, then you might want to choose a camera that Zoneminder already knows about. And the challenge there is there are more no-name cameras out there than you could possibly imagine. And then there are fewer, 10s, 20, 30, 40, something like that, sort of main brand cameras out there that would be built into Zoneminder. If you're looking at Blue Iris, they probably have exactly the same thing. I don't know for sure, but if you've decided that you want to be using a particular surveillance camera software, then you might want to look at what cameras it already knows about and maybe choosing cameras that are compatible with it. What I will say is if you buy an RTSP, or you already have an RTSP camera, and then it will work with Zoneminder, you may need to know, oh yeah, it's on, you may need to know the details about it, and I'll show you how to set that up. But an RTSP camera will be able to be recorded on Zoneminder just fine. So I think then the only other things to talk about on cameras are going to be consider the resolution. So 4K cameras are fairly common now. That's a pretty high resolution. There are cameras that are beyond 4K, and then there are a lot of 1080p cameras and down. The choices there are going to be revolving around how much do you need to see. If you want to be able to read license plates, you're going to need a pretty high quality camera. If you just want to see, did something happen there, then you don't. Oh, look, a person walked by there is a very different requirement. The second thing to be thinking about is frames per second. Oh, by the way, if you have a high quality camera that can do 4K, you'll also be able to stream at a lower quality. So if you have a high quality, you don't want it, you certainly can use it and just use a stream that has lower bandwidth in it. The second thing to be thinking about is frames per second. A lot of these cameras will do 30 frames per second. That's pretty much the same speed that I'm talking to you now at. That looks like full motion video. A lot of security cameras don't really need that. It takes up a whole lot of data. And if you're just trying to see, did something happen, then often 5 frames per second, 8 frames per second might be sufficient. And that, one, reduces the computing effort that the security surveillance software has to do, and two, reduces the storage that you need. If you want to have a month of storage, then you're going to need some terabytes of data. How many terabytes is going to be dependent on how many cameras, what's the resolution, and how many frames per second. So you can bring down the frames per second both in the surveillance software, but it's more natural if you just bring it down in the camera itself. And every camera I've seen, you can specify how many frames per second you would like it to be recording up to its maximum. And if you do it in the camera, then there's just a lot less processing power going on everywhere else. So that's the natural place to do it. And now I want to talk a little bit about Zoneminder. So Zoneminder is a piece of open source software. The link to it is in the comments below, and the documentation is in the comments below as well. In fact, I'm going to put two documentation comments in there. One of them, sorry, two documents in the comments. One of them is going to be the Zoneminder documentation, which is excellent. It is well written. It is well thought through. The nice thing about open source software is the documentation tends to be good. And the second one is going to be a much more specific Zoneminder implementation, just as a step-by-step. It's exactly what I'm going to be doing when in the next section where I go through how to set it up. But you can have it yourself so you can see all the commands all written down, going to mimic exactly what I'm doing. And so that'll get Zoneminder basically set up. After we do the basic setup, I'm going to attach a couple cameras to it. And then the more interesting stuff is setting up for alerts. And there are going to be a couple things we're going to look at. One is we're going to look at the definition of a zone on a camera. So a zone, by default, the entire image will be the default zone, which is sort of like here, you have the entire image from there to there and all the way up and down. It'll be the same kind of thing there, but you probably don't want to have that as your zone. So we'll look at defining the zone that's the area of interest to you. So if it's indoors and you want to make sure that that zone does not have any lights in it or things that go switch on and off or any activity that isn't of interest to you, where if you're outdoors, then you want to make sure that, for instance, you don't have trees or leaves that might be blowing around with the wind as part of your zone because you'll get alerts because the wind blew. Well, you might want it, but probably not. So the zone is useful for saying which parts of the image in particular are of interest to you and ignoring the rest. And once you have one or potentially multiple zones defined for each camera, and each camera has its own zones, then filters will specify what you want to have done if the Zoneminder detects an alert for one or more zones on one or more cameras. And those will then let you take actions. The one that I'm going to be talking about for an alert is going to be through email because it's the easiest. There are others you can use, and if it's of interest, I might go through how to get a more instantaneous one, but I'm going to go through what's probably the easiest setup of all, which is to, when an alert happens, use Gmail to send an email to whoever it is you want to send the email to, presumably yourself, but it could be to a bunch of people, that there was an alert. And it lets you specify which camera, what time, lets you send an image, lets you send video, but that probably has size issues, to let you know that an alert was detected at any particular point in time. And to do that, we're going to need to set up MSTP, which is going to be, I'm going to go through every step to do it, which is going to be the mechanism you use to send email out from your Linux server. We're going to use Gmail, and I'm assuming you have a Gmail account and two-factor authentication, which you really should have if you're using Gmail. But then you're going to use a app password, which is Gmail lets you specify a password for a device so that you don't have to use two-factor authentication for that device. And so I'll put that in, and it will then be able to send emails through Gmail to yourself in order to let you know. And then finally, we'll set up a filter in Zoneminder that says, under the conditions that I'm interested in, that is, for these cameras, we had an alert that had a score of at least some value, so don't tell me that a raindrop went by. And in that case, I want to send an email to this person, and I want to have it say the time, the camera, send me a picture, the highest score image, things like that, and ship it off when it's there. So we'll set all that up and get it working for one of the cameras. The Zoneminder is going to need to store a bunch of data somewhere, and by default, it puts it at some crazy location in a cache, which we'll see in just a second. So what I want to do is to basically first create a place that has a whole bunch of disks for storage. If your data is critical, then you probably want to use ZFS and mirroring. If you are not, if you don't have, if you're low on memory space, then you might want to be using LVM, which is the Linux logical volume manager, which will be less memory intensive, less processor intensive, but it doesn't give you warnings on failures, at least not as well. I'm going to use ZFS again, but I'm not going to use it as a mirror here. I'm going to use it striped, which means I get the total space is going to be the combination, the combined of the two drives. If either drive fails, I lose my data. But on the other hand, I get a lot more data. What I would be doing if this were important is I'd be having one set of data and then I'd be doing fairly regular backups in order to back up the data somewhere else if data security was an issue. So ZFS, we're going to do a Z pool, create FO50 equal 12. Again, this is an optimization. Look it up for the details on it. And I want to call it Zoneminder Data. And I'm going to use the two drives, SDB and SDC. And they are each 6 terabytes, if I remember. So once I make that, if I now do a Z pool status minus V, I see that I have ZM data and it consists of those two drives. And a df-h of /ZM data shows me that has 11 terabytes. So I now have 11 terabytes to store video. Because we want Zoneminder to store all of its data in the ZFS directory that we just created, what we can do is put the mount the ZFS directory where Zoneminder by default sets its data. We could also create a symbolic link and so have the normal place where it puts it linked to the Zoneminder directory file, but this one is, I don't know, same diff. So if we look at cd/ls, let's just do this a little bit better. We can see that ZM data is the ZFS file system. Z pools, typing right, status-v. We can see that ZM data is our pool. It's got our two drives. The place where Zoneminder by default puts everything is going to be in cd/var/cache. I have no idea why, but that's where it goes. Chances are you can set some switch to make it go somewhere else. And in there, we have a bunch of different things. But here's where I'm going to go and put the mount point. So I want to do a ZFS set mount point equal /var/cache/Zoneminder, and the pool name is ZM data. Now in var/cache, we see that we have a Zoneminder directory. And if I go into there, cd zone, well, let's just, before I go into there, let's do a df-h. How much space is here? We have 34 gig available. Once I go into Zoneminder, df-h dot, I've got 11 terabytes available. So this var/cache/Zoneminder is now my ZFS directory, and it's got a bucket load of space in it. In order for Zoneminder to tell us when an alert has been triggered, I'm going to show you how you set this up with using Gmail so that Zoneminder will send you an email and through Gmail in order to get in order to alert you and send you a picture and do things like that. The first part you need to do is to set up your Gmail account. A couple things that are required there. One is that you have to have a Gmail with two-factor authentication enabled, which hopefully if you have a Gmail account you already have. And once you have that, you want to go to myaccount.google.com/app-passwords. It's all one word, APPPASSWORDS. And there under signing into Google, you're going to click app passwords and generate one. And the app password is a 16-character string that can be used from only one place. And the idea is that your application can now access your Google email account using that password, and it can only be used there. So I'm going to leave it to you to go to, again, https://myaccount.google.com/app-passwords and generate an app password for your Google account. Then we have some things to do on the Linux side of the world. The first thing we need to do is to go and install something called MSMTP. And that is a application that is SMTP ready. And what it will do is let us go and send emails through SMTP to the Gmail. And we now need to go and install apt install MSMTP, which will go put that in for us and let that go install it. And now we're going to need to go and create a user file for it. Configuration file for it. And the configuration file is actually pretty simple. You can put it in your local directory if you have multiple users in there. I'm going to put it in /etc because this is a single use processor, so it just can go right in /etc. I won't make you have to watch me typing it all in. That would be painful. This is what your MSTP-RC file in /etc needs to look like. We have some default values. We have authorization is on, TLS encryption is on, and then the trust file is going to look up the standard place for the certificates, certificate authority certificates, and a log file. You might want to have this in your home directory. You might want to have this in /var/log, kind of up to you. And now you can have multiple accounts defined here, but here's where I've defined it, the Gmail account. It's going to have account as Gmail. The host, that's a standard Gmail host, smtp.gmail.com, a standard port for 65. Start TLS is going to be off. This is going to be your user email. I suspect that already exists. It's not mine. I just made it up. So it's going to be your user mail at gmail.com, and it's going to have the user is your user mail. And the password, and this is the password app that you will get from Gmail when you go into getting a password app. It'll be 16 characters. You'll want to make sure you put some quotes around it because there are spaces in between them. And then you need to specify your default account. So account default : Gmail. And you'll want to leave the spaces in there like this so that it all works fairly well. So once we've done that, we can go and create a test message to make sure it works. Nano message text. And say we're going to use to some person you know, somebody at somewhere.com. And we can have a subject of test me. And then the body of the email will be, this is a test. And it's now going to go and create, oops, I don't want to be doing that. I want to be doing Control O. We're going to write that out and Control X. And now I can do a MSMTP-T input message, and it will have sent that message out. And somebody at somewhere, well, I cheated and used a different text that actually has a real email in it. That email is now going to go out and get sent. And if you go to wherever you sent it to, you want to make sure that you in fact got that email with that subject and that line. And when you have that, then MSMTP is set up on this machine. Now I'm going to point out the security hole here. I'm assuming this machine is used for very few things. People are not logging into it. The password of the email of the password app for Gmail is in plain text in a file in /etc/MSMTP-RC. You can use a keyring to encrypt that password and then use it from the keyring. If that's of interest to you, put a message on there and I will, comment in here, and I will go add a little video on how to go set up Gmail app password in a keyring so that MSMTP works and your password is not stored in open text. Now we're going to install Zoneminder on a clean Ubuntu server that was installed with the minimum configuration. So it has pretty much nothing on it. So first we have to do the setting the time zone. Everything we're going to do here, by the way, is right out of the Zoneminder wiki, which I'm going to give you a link to in the comments, and we're simply going to follow exactly those steps. And the first step is to do a time date control. And I'm going to do a little bit more here because we're going to look at the options so you can set up for your time zone. So we're going to log in as test again, and the password is ever so cleverly test. And we're going to take a look and see what time zones are available. You do an ls/user/share/zone info, and it's going to give you a list of the continents. And I happen to be in America, so we're going to do the same thing /America, and this will show me all the different time zones that I can choose of the Americas. So now that I know that, I can do a set time zone for my particular time zone. And that's going to be time date CTL set time zone. And for me, that's going to be America/Los Angeles. And let's try something went wrong here. Set time date CTL set time zone. There we go. Much better. Okay. Now, the first thing we need to install, as it points out, is LAMP, which is the Linux Apache MariaDB, which is a database, and PHP, or P for PHP, which is a standard language service that gives us all the general tools we use for anything that's running a web service of some sort. apt install h2 php server php-mysql lib g2 mod php. Okay, and we'll probably skip a little of this because it's going to take a few minutes to install it all. Now, the server is going to come up when it is, anytime the system is booted, and we can set options for it. So that's where we can use Nano, which is a very simple point and shoot editor, /etc db conf.d 50 server. Just the 50 sort of specifies when in all the different boot things, the boot series that it comes up. And I want to make sure that we have, oops, I'm typing for VI. Let's use arrows instead of VI commands. Somewhere near the bottom, we'll find we put them in. We want to have these 3 lines, again, right out of the Zoneminder wiki. So I know DB file per table is on, buffer pool size is 256 megabytes, and log file size is 32 megabytes. So that's what we want to have. Control O to write it, and we want to leave it with that same name, and Control X to exit. And we're now going to do a service SQL restart. Force it to go and read in the variables we just put in. Now, the wiki shows you typing in this entire script and then executing the script. I'm a little more basic than that. I just type in the commands that are needed there. So they have apt install y software common, put that in, and add apt repository. So what that is going to do is basically tell apt about the existence of Zoneminder. PPA colon Zoneminder hyphen 1.36. In now, when we do an apt update, you can see that's the next command in there. We do apt update because that it's now going to go and look for all the updates, including Zoneminder. It looks like there's something to be upgraded as well. Apt, anytime that's happening, I'll just do the quick upgrade in there to get it. Snapd, that can wait a little bit. And we're now ready to install it. Apt install -y Zoneminder. And now it knows where to get it because we told it about where to find the repository. And so now every time we do an update, we'll also update Zoneminder along with any other software packages that we might have. So once Zoneminder is in, it doesn't automatically start up on boot. And we want to make sure it starts up on boot. And that's the next command. So systemctl enable Zoneminder is going to turn it on. And that enables it to be started on boot. So the systemctl start Zoneminder will just start it. Systemctl enable Zoneminder will say always started on boot. And now that we have that done, we'll do a systemctl enable Zoneminder. And they do a service Zoneminder start. We could do systemctl start Zoneminder as well. Start should work just fine though. We are running. The other ones we're going to do is going to be add user www data. So we're going to add a user that that Zoneminder will run as, and we're going to enable Zoneminder on Apache to enable mod is going to be rewrite to enable to so just modifying some of the capabilities of Apache at the moment. And service Apache to reload so that it goes and reads those modifications. And we are done with that one. So at this point, we have Zoneminder up and running. So Zoneminder has been installed, and I now go to a web page that happens to be the IP address of the video of the machine I was just looking at. So it'll be HTTP, the IP address you had. You can see that via ifconfig/zm. And when you do that, it'll bring up its index.php. If you just go to the web page, you're going to get a default Apache page, which you don't really want. So ZM is where it actually puts all of the Zoneminder. It's a subdirectory in under the default HTTP directory. And here's where everything lives. And you can see the about, the contact, the cookies, all of kinds of things there. And we're going to accept and apply so that we come in. A couple of housekeeping things in setting up Zoneminder. In the options system, you want to make sure of a few things in there, one of which is going to be your time zone. So if you don't set this, it will complain about not knowing the time zone. So set it up for whatever is appropriate for you. America, LA is right for me. And then there are some security things. If this is entirely inside your subnet, you don't probably need to worry about it. But if you're going to allow any kind of access out, then there are going to be some things you want to set up. The first one is a hash secret. It will hash passwords. And so you'll want to take your hash secret and, as it says, change to something unique. That will take your password and hash it along with your unique hash secret. It makes it a little bit harder to decode passwords if somebody gets a hold of the hash. You can also include the IP address in there if you'd like to do so. The other thing is want to make sure that you are going to use authentication. That means that your users need to log in, and you can specify your users here. You have an admin user that you set up originally, but you can add more users. And I think that's most of it. There's one other thing here. You can turn on reCAPTCHA. It makes it a little bit harder for password crackers. So you can add the reCAPTCHA to the log page. You can have a site key, and you can look up all of those in there if that is important to you. Finally, by default, Zoneminder is using Apache, and by default, it's going to be using port 80 on Apache. So if you have both Zoneminder and Nextcloud on the same machine, that'll work just great, but you'll want to get Zoneminder onto a different set of ports. Additionally, if you are letting Zoneminder talk out to the real world, then you want to be making sure that it's talking on HTTPS rather than HTTP. Both of those are standard Apache configurations, and that's going to be in /etc/Apache, and I won't talk about that here because that'll be a whole other topic. If you'd like to have setting up Apache HTTPS covered, put in a comment. I will make another video. It won't be that long, but I don't really want to add it in here. Now we have the ability to add a source. Let's take a look at the IP camera to go and find a source to connect it up to. So I've just taken a camera, brand new camera, never used it before, and hooked it up. This one I hooked up via Wi-Fi because, well, it's easier for me to do from here right now. And I went to its website, and you can see it's now looking nicely out the window. And it comes up with monitor mode, so you can look and see what's going on there. And it's got PZT, so you can zoom in and out and move a little to one side and move a little to the other side. But more interesting for setting up for Zoneminder is going to be the settings. And every camera is different, especially if you have no-name cameras, kind of like this one. And so it's going to have the media in there. And we'll just go through these a little bit. So one of the things to note is that the first, it has a high quality stream and a low quality stream, and you can choose which one you want to be looking at. The high quality stream, I tend to use full resolution, and you'll notice it's coming in at 10 frames per second. From my viewpoint, that's a little higher than I need. So I might bring it down to something like 6, something like that, just to reduce the load on the security camera software, and more importantly, reduce the total amount of disk space that this thing's going to eat up when it starts recording. But it also has a lower quality stream. In this case, looks like 1080p, and also still has 10 frames per second, but I'm going to leave one there because I don't really care. And just hit apply on that to save it. And we'll just briefly go through these, although I won't really touch them. So I can have a timestamp turned on. I can give it a camera name. Camera name is IP camera. This is going to be my test camera, ever so cleverly named. And the image, you can now see it says test over there. It's got the time there. And oh, look, it's 2023. We'll have to fix that. And this thing can record audio and some basic settings there. I'm going to leave it on auto mode, and night vision is intelligent, so it'll go and turn that on when it needs. So in the network is going to use dynamic IP address from the DHCP server, and RTSP is going to be, the HTTP is port 80, that's what we're on right now, and the RTSP port is 554, which is a standard RTSP port. And I believe the permissions check is a way of making sure you have to log in, and there's definitely possible to do that. We'll talk about that in a bit. We're on the wireless, but that just happens to be on a particular wireless IoT. subnet that I just perked it there. I did already block it so that it is not allowed to talk out. And dynamic DNS, we don't really have. ONVIF, if you're trying to use that, yes, thank you. We don't need to have that. It's going to be on server port 8080, which is a standard, and you can tell it what you want it to be able to control. And P2P is if you are trying to, we'll ignore the P2P. So we're going to go from the ONVIF. If you decide to use that, it's turned on. It's on the standard ONVIF port, and you can go and use that. We'll talk about that later. Alarm is if you want it to go and detect alarms. In this case, I won't be using that. I'm going to be using Zoneminder to find alarms. So I'm going to ignore this one entirely. Advanced will have users, time record, email, and FTP. I don't let this thing go out, so it doesn't use any of the things. And it can have cloud, so you can have it do cloud recording. There's no way I'm going to trust any of my IP cameras to go talk to the cloud. The one thing I will want to do is have time server, the NTP server. In this case is, I don't let it to go out on anything, so I'm going to have it set it up to 192.168.2.254, which happens to be my zone alarm IP address for this particular subnet. So this should now allow it to go and get time. And let's see if it can do that. It is still not 2023. Oh, every hour. So I guess it'll take a little bit to go and talk and find out about it. Initialization. I'm not sure what that's good for. Device information, so you could find out a little bit about who makes it. You can see a bit of the DNS, and it can take a card, but don't care about that. So at this point, and you can look in, if we look at the logs, you can see that it actually updated the time zone and it updated to the current date, which is there. So now if I go to monitor, I should actually see today's date. Isn't that great? Now you can see when I recorded this. So now that we have the IP camera set up, we'll want to go to Zoneminder and hook it up there. So we have Zoneminder, and I've gone and I'm going to go click on the console, and we have no cameras and nothing connected up. So we're now going to add a camera. And there's going to be, the source is going to be the main thing we want to make sure we get right. But here we're going to call it test cam, and it does not have a server on it, and FFmpeg, and this tends to be a pretty good number here. I don't set a maximum frames per second because I set that on the camera itself, so I don't have to have Zoneminder trying to bring that number down. And the source path in this case is going to be RTSP://192.168.2.25 colon 554. And now here's where you need to find out what the RTSP is for any particular camera. This one happens to have it set at 11. What I do is I use a various, for either Windows or for Mac, you can get an ONVIF camera app, and it will go and scan and find those ports for you. Alternatively, you can look it up on Google. There are probably other ways of doing it. I've never bothered figuring out what they are. We're going to use TCP. And in this case, the resolution, which is what we have to set, this happens to be a 4K camera. So we're going to go down to right there, 4K USP. And the only other thing I'm going to set right now is going to be the buffers. I'm going to allow this to go to 5 and pre-event image count. I'm going to leave some pre-event and I'm going to leave some post-event. And I want to have alarm frame count of 1 that basically says if I get one really big event, well, all it needs is 1 frame of it in order to go and create an alarm. You could set it to 2. That will prevent the bird flying by from causing an alarm. But it'll also mask out some things potentially. And we're going to save it. So once we saved it, it usually takes a little while to come around. And so now I'm going to just go click into test cam, see if we have it. Looks like it's getting there. And there it is in test cam. So at this point, we actually have our camera. And I'm going to go back to console and the function. So here we're going to look at the function. Right now it's set at mode cord. Let's just go through a couple of what your options are. You can just have it monitor. That is, you can see it, it will not save anything. You can just have it record. It will save everything and not do any analysis on it at all. The two that may be of interest are motion detect, where it will start recording before, during, and after it detects motion, and it won't be saving data any other times. Or you can have it go on mode cord. Mode cord happens to be what I tend to use, which is it's always recording and saving, and it's giving you events if something happened. So that means I have 24-hour data capture, so I can look at all of my cameras at all times across wherever I want to look, and it will tell me about events that may happen. So I happen to like that. And then you can see when there are events, and you can see when there are, what time of day and week and things of that sort. And now the next thing I want to talk about is setting up for alarms. Right now, our test cam has a zone. So if I go click on the zone button here, it's going to show me that the zone is the entire scene, which is probably not what I want, because it means any change anywhere is going to cause an alert. So what I want to do instead is I'm going to add a new zone, and you have these little pull things. So I could say, oh, by the way, the area of the picture that I care about is going to be, let's see if I can take that. Let's just say I want to see if this light turns on or off. That seems like a pretty silly thing to do, but that would make sense. I don't want to capture the trees if there's wind. I don't want to see the reflections, because this is a reflection, that's a reflection. I guess that's the actual light. So we're just going to look for the reflection of the light here. I'm going to set it up just like that. And there are then all kinds of, how much of the alarmed area, how much of the filtered area, how much of the blob. I'm going to name this one. I'm going to call this light changed, and I'm going to choose a preset. And you have predefined presets for low, medium, and high sensitivity fast analysis, low, medium, high sensitivity with better analysis. That will take a little bit more draw. So I'm going to do best analysis, low sensitivity, and it'll fill out those numbers for me with what it thinks is a good guess. You can, of course, play with them as you need to based on, well, what I do is I try it out and see how well it works. And if it either doesn't alarm or it alarms too often, then I go look at changing it. So I'm going to save this. I now have a new zone called light changed. And I don't really want the all, because that doesn't do me any good. So I'm going to mark it and delete it. So now I have one zone. And if I give this a little bit of time, it'll actually fill that in with a picture, but I don't really care about that right now. It's working at it. It'll eventually fill in. There it is, the whole thing. So I now have a zone for this camera that is of interest. And if I go and I look at the console, I can see that I now have a couple different events here. I click on the events, and it would show me the different events that are there. It's just continuous, and I'll provide a little example. And if I were to click on the ID of the event, then it'll show me what it's looking at. And this right here is the button that I like, particularly when I have multiple cameras. If I had 4 cameras, it will show me what all 4 cameras are seeing all at the same time, and it will tell me when there's been an event in them. So here I only have 1 camera, so it doesn't help a whole lot. But if I had, I'll put another camera in a little bit so you can compare it and contrast that to get a little bit of a feel for that. Zoneminder is up and running now with the test camera we had set up before, and I just added another monitor that's looking out over a city, so you can see what it looks like right now. It's nighttime, and there it is, and a lot of little lights, nothing very particularly interesting. But I'm going to use that mostly so that we can look at what happens when we have alerts. We're now ready to go and set up for email alerts. And to do that, we'll go to Options and go to Email. And we'll want to click on Opt Email. And in the message address, you're going to want to put in the address that you're going to send it to. That's going to be your address. This is the header. It'll be Zoneminder Alarm, and I'm going to point out what these are in just a little minute, but they give you a little bit of information about the alert if you want that. And there are all these codes that will give you the various different pieces in there. I'm going to click on New Mail Modules. I'll leave that on localhost. From email, that's going to be your email address. The URL, if this Zoneminder is on available publicly, that is, you are natting addresses in so you can see it from the road, then you can put that in if you want. It'll give you a link right to it. We're going to click on SSMTP email. And right here, we're going to put in, there it is, /user USR SBIN SSMTP. And that'll be the executable path. And we can save that. And I will later go in and put in my email address. And this should be most of what you need there. The last thing we need to get an email from an alert is to set up a filter. The filter basically tells us what we want to do on certain actions. So if we want to, for instance, the filter will go and do a purge when full. There's a built-in filter that will, when the disk percentage is greater than or equal to 95, it will go and start deleting all matches with in reverse order. So it'll take the oldest matches and get rid of them, and it runs it in the background. But what we want is a different kind of filter. We want to go and create a upload on an email. So we can have a email alert. We'll call that what we want. And we're going to specify by monitor ID. So right now monitor 1 is the one we set up, and that's going to be in here. So monitor ID is equal to a 1. You could, of course, just have all of them. And we're going to add some more filters in here. One of the things we could do is we could set a maximum score. Find that somewhere in here. Maximum score, we could say that needs to be greater than or equal to, and we can pick a number here. So I end up being around 30 for outdoor cameras, but that's really just your experience. You can go try it. I'm just going to put a 20 in there right now. And you could even say, and have the average score be something if you want to do, and you can say the number of frames that have to be there, anything along those lines. So the average score is greater than or equal to, I'm just going to put that at 10. That's fairly low. And then we're going to ascending, and we want to limit to the first, it's not going to be more than 5, but we'll just put the first 5 in there. And we want to do an email details of all matches. Email 2 is going to be your email address. The subject could very well be Zoneminder Alarm. And again, I'm going to show what these are in a little bit, but mn %, 9%. And in fact, let's go take a look at those. The %mn and %ei are all codes that are defined in the zoneminder.readthedocs.io. I will give you a pointer to that in the description. And the %mn here, it has all of the possible things you can use. So they had %mn, it's the name of the monitor, and the EI, you can see they have all the different kinds of things in there. The EI was right there, the ID of the event, and you can show the average score, you can show the total score. One of the things I like to do is actually attach either the first alarmed event, the analysis image, or this is the one I tend to use, EI1, attach the first alarmed event image. So you actually get, in the email, you get a JPEG in there that just has what it got triggered on. But as you go through these, you can see there's all kinds of things that you can tell it, the number of events, the time, on and on and on. I'll let you go through those at your leisure. And again, This website, the zoneminder.readthedocs.io, has in the filtering events, this is really all of the documentation on Zoneminder, and it's really good. But here you can read everything and anything about it. But let's go back to this real quick. So the email body, you could do something like ZM alarm. So any text you put in there. Kinds of things that I like to have are seconds. I might put in %EL percent. I might decide that I want to know the score, which is a %EST percent. I'll often want to know the time of the event. And for my outdoor ones, that's particularly useful because I'm going to get an event anytime it switches from color to black and white, or black and white to color, down during dawn or dusk. And then if the other one I'll just point out, you can do alarm image, and this is where we'd have that %EIM percent. This wouldn't be the first. That would be the image that had the maximum score is attached there. At any rate, you can do that, and you'll be all set. Then we'll want to run the filter in the background so that it's running all the time. And the only other thing we need to do is to click Save. And at this point, this is running. And every time there's an event, you will get an email. So we've restarted Zoneminder, and we're looking at the log files right now. And it's red because there are errors in there, and there are errors in there because some number of pages back I just put in the cameras. Once you have your cameras set up and everything is running right, this should not be red because you should have no errors in the log file. Right now, if I were to go and search back for a little time, it'd say, the camera doesn't exist, and the various errors that came in from setting it up in the first place. So now I'm going to go and I'm going to wave my hand over the front of the camera. So a little hand wave, and we see that it's gone into alert state. Not much of an alert state because it was just a hand wave in front. But I guess there are 5 images of it. And you can see that it doesn't immediately go and send an email. It's taking a few seconds here. And we're back into capturing, which is all very nice. And now we have sent an email. So that's the downside. There was 10 seconds or so till that finally happened. And the good part is if timing is critical to you, well, Zoneminder has an API, and that API can be used in order to go and provide much more instantaneous notifications if that is needed. On the other hand, this works pretty well. I'll have an email in another, minute or so that shows me my hand in front of the camera. So we've gone through how to set up IP cameras and keep them secure using some of the information from pfSense, and record and store and alert you to any events that the cameras catch. One of the things to keep in mind is the security of your Zoneminder itself. If you want Zoneminder to be visible from the outside, which you probably want to do so that if you get an alert and you're somewhere else and something happened on your driveway, you'd like to be able to see it. That requires that you have Zoneminder be given NAT access, which is something we talked about in the pfSense video. And you'll want to make sure that you've got it only enabled with SSL, so it's HTTPS access, and you have to log in, preferably with reCAPTCHA or something along those lines. And if you are very security minded, then you'll probably want to have that all happen through a VPN. In this case, this would require a server-side VPN so that you need to log in through pfSense in order to get access to your internal network at all. And that's something I'm going to be covering in a video very soon. If you have any questions, leave them in the comments and I'll see if I can answer them when as best I can. Thank you.